today we are going to be looking at the different types of quadrilaterals. We're going to be taking notes on the 5 that we're going to learn about, and your goal pretty much for quadrilaterals is being able to memorize the features of each quadrilateral, because you'll be given a shape and they will ask you what quadrilateral is it. So this one is really just a memorization lesson, which is kind of like the triangles, just something you have to memorize and be ready to know. So I'm going to put quadrilaterals, page 123. Okay, so it's our objective. So today I will learn about the types of quadrilaterals. Alright, let's define what a quadrilateral is to start. So a quadrilateral, quad means 4 of something. So this one is a closed shape with 4 equal sides. Okay? Oh, sorry, not equal. How about that doesn't make sense? 4 straight sides. Okay, so it's a closed shape with 4 straight sides. Okay, I'm going to do kind of like a chart on here that I want you to write down with me. So we're going to write the name here. This will be the name of our quadrilateral. These will be the sides. So what do the sides look like? What are the characteristics of the sides? And then if there are any specific angles that go with it. Okay, so we have name, sides, and angles. Another thing is, I'm just going to sneak it up here, is that this symbol that we might see on the different quadrilaterals means it's a right angle. And we've seen that on our triangles. And then when you see slashes like this, or like this, those mean that they are congruent, which means that they are the same size. So sides that are congruent, which means same size.
Okay. All right, let's take a look at our first one. The first one that we have is a trapezoid. And it looks like this. Okay. It has at least one pair of opposite sides that are parallel. Oops, spelled that wrong. Double L, not double R. So it has at least one pair of opposite sides that are parallel, which means that they will never connect and they will go on forever. So these are parallel because those would be parallel because they go on forever. These would not, because this is at an angle and this one's straight, so eventually they will meet and be perpendicular. So it has at least one pair of opposite sides that are parallel, and then angles is nothing unique or special. So with a trapezoid, there's no unique type of angle or anything. So all you're looking for is if it's a trapezoid is if it has at least one pair that is parallel. Okay, so let's draw a line. And then number 2, we have a parallelogram. Okay, a parallelogram is exactly what it sounds like. Both sides are going to be parallel to each other. So it kind of looks like this. It's kind of at an angle. So these sides are parallel and this sides are parallel. Okay. And it also has a right angle, 2 right angles in it. Okay, so a parallelogram, both sides that are opposite. So these sides and these sides are congruent, which we know means the same size. So if you measured these with a ruler, these are the same size and these are the same size, which is why we put the matching line. So by putting these two lines here and these two lines here, we're saying that they're equal and they are congruent. Okay? And then both pairs of opposite sides are parallel. So these are parallel, they go in the same direction forever and they will never meet. These sides are also parallel and they will go on forever and they will never meet. For the angles, the opposite angles are equal. So these angles are equal if you had a protractor, and these angles are equal. Okay, let's go to number 3. I'm gonna extend my lines. And then I probably have to go on the back too. So number 3 is a rhombus. Okay. And it kind of looks like a sideways square. It's like kind of tilted. And by putting this line here, I'm saying that all lines are congruent and equal. Okay, so all sides are congruent, which means the same size. And then both sides of opposite pairs are parallel. So these are parallel, they go on forever and ever, will never touch, and these sides are parallel and they will go on forever and ever, never touch. And then our angles, opposite angles are equal. Okay, so I had to make a new chart on the back just because I ran out of room. So if you have room, keep doing that, but I just created a new chart. So we have 2 more left, and these are ones that we're super familiar with. So we have a rectangle, which we know, all of these are right angles, and these are congruent and these are congruent because they're the same size. So with their sides, rectangles, both pairs of opposite sides are congruent, which we know because these are congruent, they're the same size if you took out a ruler, and these are also congruent. Another one is that both pairs of opposite sides are parallel. So these 2 sides are parallel, they go on forever and they will never touch. These 2 sides are parallel, they will go on forever and never touch. And then we know their angles, they have this little square, so we know that all angles are right angles. So all 4 angles are right angles. Okay, and our last one is a square, which we can draw here. Oh, sorry, my square's a little wonky. Your square is probably a lot better. All the sides are equal, they're congruent, and they all have a right angle. So all sides are congruent, which means they're the same size. If you took out a ruler, they would all be the same size. Obviously mine's not, but if you saw a square, it would be. And then the opposite sides are parallel. So these are parallel, they go on forever and never touch. And these two sides are parallel, they'll go on forever and never touch. And then same with the rectangle, all four angles are right angles. Okay, so I'm just gonna bring my line down, and then I just wanna do a sample of what you might see. So let's say that they give you a shape that looks like this, and they name the line segments. So we have M, F, S, and R. They put these right angles in. And then they also do our congruent lines. Okay. And then we have our lines that show that they are parallel. So we would look at this and we would think, okay, what is it? It's a quadrilateral, but which one is it? Is it a trapezoid, a parallelogram, a rhombus, a rectangle, or a square? So we kind of have to think about, what does this shape have? So it looks like all four angles are right angles, which means it has to be a rectangle or a square. So let's hop over to the sides. For a square, all sides are congruent, which means all sides are the same length. We know that because it has a single line here, 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 and here. If it was a rectangle, it would have a double line somewhere. So this is going to be a square because it has four congruent sides.
So for example, line segment MF is parallel to what? RS. And then MR is parallel to FS. And then if we look at perpendicular, we could do FS is perpendicular to FM. So FS and FM will meet, if you kind of extended this line and extended this line, they would meet at the intersection of F. We also have MF is perpendicular to MR. So MF, MR, so they meet right there. We also have SR is perpendicular to SF, and RS is perpendicular to RM. Something to keep in mind is that some quadrilaterals can be more than one. So for example, a square is more than just a square. It can also be classified under a different one. So it is a square because it has four congruent sides, but it's also a rectangle because both pairs of opposite sides are congruent, yes, and both pairs of opposite sides are parallel. So yes, it is a rectangle as well. It's also a rhombus because all sides are congruent, so it falls under the rhombus, and both sides are parallel. It's also a parallelogram because this is MF is parallel to RS and MR is parallel to FS, so it's also a parallelogram, and then it's also a trapezoid because at least one pair of opposite sides are parallel. So MF is parallel to RS, so it does fall under the trapezoid. But if you think about, a trapezoid can't be, not all trapezoids are a square, and not all parallelograms are squares, not all rhombuses are squares, not all rectangles are squares, but a square is a rectangle, a rhombus, a parallelogram, and a trapezoid, if that makes sense. So once you kind of figure out the big one, so it is a square,